So we all know how important it is to understand what is going on in our soils, particularly in terms of their nutrient status, so that we can make sure that we're supplying adequate nutrition to support crop growth and production. But how we go about obtaining this information can vary greatly with different levels of detail and accuracy. So for the next 10 minutes, together we're going to dig down into the three main soil sampling methods and just have a look at how each one compares in terms of their placement of fertiliser in the paddock, the costs associated with the sampling method, as well as their overall profitability. To do this, I'm going to use some of the data sets that we have generated through a grid sampling project that we established in 2022. And this was funded under the National Landcare program. Just before I go into the different the soil sampling methods, I'll just provide a little bit more background about the project. So in 2022, working in collaboration with a couple of local growers, we set up 2 by 60 hectare paddocks near Birchip. One was located at Currio and the other one at Warren. These were grid soil sampled for soil mineral N, as well as a range of other nutrients, including organic carbon, chloride, magnesium, sodium, sulfur and boron. These paddocks were also EM38 mapped in 2022. That assessment was all done by Precision Agriculture based out of Ballarat, who took those assessments for us. We used variable rate technology to spread our urea in season, and we used a N-bank nitrogen management strategy to apply our N rates. So for each of the paddocks, we set our target to be 125 kilograms of nitrogen per hectare. Now we'll just delve into the different soil sampling techniques. So the first one off the rank is paddock scale method. So this one involves taking soil cores randomly or along a transect in the paddock. In the example I've got here, this one is going in a zigzag pattern, but you could also do it diagonally. These soil samples that you collect here are then bulked up into a composite sample and then sent off for analysis. This method can be quite cost effective in terms of sampling cost. However, it does ignore the fact that soils are inherently variable, and by using this approach, you can often end up with areas of your paddock receiving more and less nutrition. Oops. Just to highlight this point a little bit more, I've got a couple of different transect options here. So this is using some of the grid soil sample data from the paddock at Currio, and I've taken 2 different transects approach. So transect 1 is just diagonally across the paddock here, and when you average out the values that we got for the grid sampling method, it came up to 102 kilos of nitrogen per hectare. I then selected a different transect, so this is just with a wonky line across the paddock, and averaging those values there, it came out to 87 kilograms of nitrogen per hectare. And that worked out a difference of 15 kilos of nitrogen per hectare, depending on which transect you took. As a result of that, each of those different transects resulted in different amounts of nitrogen being applied in the field, and as well as different costs. So just looking at the urea price, you would have been 25 hectares either higher or lower in your cost of nutrient application, depending on which transect you took. So I just really wanted to highlight here that it's really important to note just how heavily you are relying on the person doing the soil sampling to correctly select the most representative area of your paddock. As you can see here, depending on which transect they take, you can end up with very different values of the nutrient that you're wanting to correct, and that can have subsequent flow-on effects into terms of yield and things like that. The other issue with this method is that it potentially, depending on your paddock variability and what nutrient you're wanting to correct, has a very poor match-up to what nutrients you need to supply for crop growth and what the soil currently contains. So I've got another example here, just using one of the transects from earlier. We've diagonally soil sampled across the paddock and averaged it out to be 102 kilos of nitrogen per hectare. That's our starting soil mineral N, and if you're working off that, you would have blanket applied X amount to achieve your N-bank target. If you had done that, and apologies about the colours, I wasn't able to change these, so it might be a little bit difficult to see, but in the dark blue areas, that works out to be approximately 6 hectares, and using the values from our grid sampling data here, that would have indicated that those 6 hectares would have received more nitrogen than what they needed. If you just look at the sort of aqua areas, that equates to around 24 hectares, and that would have been about just right for that starting soil mineral N value. And around half of this paddock would actually have received less nitrogen than what it needed to achieve that N-bank target. So yeah, just wanted to highlight that there are some issues with using the soil sampling paddock scale method if you, depending on what variability you have within your paddock. So the next one I'm going to talk about is the zone method. So this one's typically based off using either the soil type differences within your paddock or production areas. So areas that are high and low yielding, have high or low biomass producing. You might notice that there's a colour difference in certain areas, a different texture. And these are often linked. So your higher areas might be more on your heavier soil types, but not always. This method involves taking multiple cores collected from each zone and then bulking them up into one sample, and then you end up sending off one sample per zone. Typically, to identify those zones, we've used a lot of grower insight and knowledge to be able to identify the areas because you've got that long-standing history of how your paddock performs. But we're in a really good position now to use some other tools and techniques to help refine and confirm our zones that we currently have identified. So you've got things like multiple years of yield maps, you've got protein maps, you've got EM38 maps, and even elevation as well. This approach might be slightly costlier in comparison to the paddock scale approach, but it does better align nutrients to where they are needed most within the paddock. And this is just some examples here of the type of data sets that you might like to use to identify your zone areas or to help validate what you're seeing in the paddock. So I've got an elevation map here, the colourful one. And this is one of the paddocks that we used in the grid sampling project. So you can see here this blue area, it has lower elevation, and up here in the red, and also shown by the contour lines, it dramatically increases in elevation. You probably can't see the legend there, but this increases by about 1 metre. And it just so happens that this elevation map actually really nicely links up with what we're seeing in a Google Earth image for that paddock. So we've got areas with what looks like either a different soil type colour or plant cover over that area, and it just nicely links up with what we're seeing elevation-wise. So if I was going to use these sets as to identify my zones, I'd probably look at something around doing a zone around these high elevation areas here in the orange, a zone, so like that for zone 1, and then the rest for zone 2, as at least a good starting point, and then you can tweak it further down the track. The last method is grid sampling. So this is one of the most robust and accurate methods for measuring spatial variability, not just across the paddock, but also at depth as well. It involves dividing up your paddock into a grid structure. You can do anything from 5 hectares. In this project, we did a 2 hectare grid resolution. And within that 2 hectare grid area, you can either do 1 core to represent the soil in that space, or multiple cores on in like a transect, and then composite that up and send that off for analysis. Because this technique is very sample intensive, it's quite costly to undertake, and so it's really important to understand when and when not to use this strategy. It's definitely better suited to those fertilisation plans and soil amendment strategies that come with a really high product cost, and ones that don't necessarily need sampling every year. So things like gypsum, lime, and in our case study, which you'll be able to see in the manual, we found that it might even be a suitable technique if you're looking to adopt the N-bank approach. So that's just our 3 main soil sampling approaches, and I thought I'll just go through some of our profitability results that we saw from some real paddock data. Just keep in mind that I've had to theoretically derive the values for the paddock scale approach here, as well as the zone, but they do tell a nice little story here. So this is our results from Curio last year. The grid sampling approach resulted in the most income when you compare it to the rest of the different strategies. But when we took into account the sampling costs, the most profitable approach was the zone. These results were a little bit different to what we saw at Warren. The zone approach came out to generate the most income, and it was actually the paddock scale method that was the most profitable. As you will see here, something that we found quite surprising, that was despite the additional costs associated with grid sampling, that technique did not result in hundreds and thousands of dollars difference between comparing these overall profitabilities. If you look here, the biggest difference between Paddock, which was the most profitable, to the least profitable, the grid average, there's only $46 per hectare difference. And as you saw in the earlier slides with the different transects you would have taken at the Paddock scale approach, you could easily get that cost difference just by taking a different transect when you're Paddock sampling. So in saying all that, which method is best? Well, we know grid sampling has the highest sampling cost. However, in variable soils, Paddock scale sampling can do a poor job in matching the application of nutrients to the soil needs. Zone approach does a much better job of that, and then grid sampling is the ultimate in that space. Your return on investment for these different sampling approaches really does vary depending on what issue you are trying to correct. Something to really keep in mind when trying to select which sampling method you should be using is what access you have to machinery and the ability to handle these intense data sets. There's probably no point going out and grid sampling if you don't have access to a variable rate spreader or someone who can contract that out for you. Because I can't imagine there'd be too many people in this room going around manually adjusting their nitrogen rates to a grid or sampled map. And lastly, our early results are indicating that grid sampling might be a suitable strategy for adopting an M-bank approach, but we definitely need more years of data to validate this.